Okay, let's give you guys some more practice. So somehow integrate this. So press pause and have a go. Okay, so this one's like the one in the previous video, but here you've got a combination of a linear and a quadratic. So when it's a linear, you can break it up as a so when it's a linear here, this will be a constant. So here you've got a quadratic. So this here will be a linear. So we can break up this fraction as one fraction plus another fraction. So now it's just a matter of finding out a, b, and c in such a way that this whole thing here will equal this. So to do this, we're going to merge these two fractions. So times top and bottom here by this thing here. So that would be x squared. Yeah, that will then give you this, and then this one here times top and bottom by this thing here. So this thing here will then, well, the whole thing here will then become this. So because you're trying to find out a, b, and c, you don't really well, this is already the same as this. So let's just concentrate on the numerator. Let's just look at this bit here. Okay, so let's just look at this bit here. Okay, well, if you just look at this bit here, well, this whole thing here will then become this, because if you multiply this out, that will then give you this. Multiply this, that will then give you this, and so on. If you look at this here, this times this, that will give you bx. This one would be 2b, and then this times this will be cx squared, and so on. Okay, so we're and then group all the x squares together. So that would be a plus c, and then group all the x's together. Single x here, you've got a single x here. So group this with this together. That will then give you this, and then this here is a constant. And then, well, single number, merge the two together. That will then give you this. So now if you look on the left hand side, there is no x squared. On the right hand side there, well, because on the left hand, so this here is a constant. You see, this here is a constant. So you know that this has to be 1. And then if you look on the left hand side, there's no x squared. There's no x squared term. So this here must be 0. And if you look on the left hand side, there is no x term. So this here must be 0. So looking at this here, you have to somehow select a, b, and c in such a way that this must be 0. This here must also be 0, and you have to select a, b, and c in such a way that this will be 1 because of this one here. Okay, so now you have to select a, b, and c in such a way that these three equations will be satisfied. So use whichever method you want, do whatever you want. A, b, and c will turn out to be this. A is this, b is this, and c is this. Use whichever method you want. You well, do whatever you want. So a, b, and c. So now we've got a, b, and c. So once you've got a, b, and c, then you can put once you've got a, b, and c, you can put this into the a, because we discovered a. B earlier was a quarter, so we can put it into the b, and c was minus 1 over 8, so we can put that into the c. So that will then give us this. Okay, well, we'll type yeah, that will then give us this, and then tidy up, and then that will then take you to here. So now, hang on, let me think. So now so this here is straightforward to integrate. This here is slightly harder. If you can somehow try to get the numerator to be the exact derivative of the denominator, then you can integrate it easily. But it's actually quite difficult to do because you've got this constant here. So you've got no choice here but to break this up as one fraction, and then break this up as another fraction. So this here is straightforward to integrate, because if you look at this here, this is almost the exact derivative. So if you integrate this, it will be a log. This is straightforward. Okay, let's leave that for the time being. If you look at this here will then be this, and then the other fraction, break this up into two fractions, and then that will then give you this. Okay, so we are currently here. So now let's factor out the constant. So that will then give you this, and then factor this constant out. So that will then give you this. Now this here is easy to integrate because this is almost the exact derivative of the denominator. So you know you've got to use the natural log. This one here, there is no x here. But the thing is, remember that when you differentiate inverse tan of x, it would then give you 1 over x squared plus 1. But then here you've got a 4 here. So to create that 4, remember, hang on, we've done this before. If you try to differentiate if you try and differentiate x over a constant, it will then give you, we've done this many times, it will then give you this. Okay, and we've done this many times. So I'm not going to go through it again. Well, if you differentiate this, it will then give you this. Remember, earlier we were here. We're trying to integrate this. This here is easy to integrate because this here is near enough the exact derivative of this. This one here, if you differentiate inverse tan of x, it will give you 1 over x squared plus 1. But then here you've got a 4. So to create this 4, if you look at this, if you put a 2 into this k here, if this k here is a 2, if you put a 2 into this k, then when you differentiate it, it will then give you a 4 here, because here you've got k squared. So this thing here would be a 4. But then you also have a 4 sorry, you also have a 2 here. Okay, hang on, let's start again. If you put a 2 in here, this would be a 2, and then this will be a 4, which is good here. But then you need to negate this 2, so this will be an 8. Well, anyway, integrate this, it will then give you this. Okay, don't forget you got to turn this into an 8. And then integrate this, it will then give you this thing here. Don't forget, when you integrate this, you would need well, we've done it many times. Integrate this. Don't forget you've got to times this by 2 because of this 2 here. Well, integrate this, it will then give you this. Integrate this, will then give you this. Integrate this, will then give you this. Yeah, so this here is your final answer. Okay.